Okay everyone, let's take a look at Module 26109-23, Conductors and Cables in the NCCER 11th edition. This will be Section 1.00, Conductors. The term conductor has two meanings. The current carrying portion of a wire or cable, a wire or cable made of the current carrying part, and the outer covering or insulator. Conductor size refers to the cross-sectional area of the current carrying portion of the wire. Wire sizes are expressed in gauge numbers. The US uses the American wire gauge or the AWG system. AWG system. Common AWG sizes range from 40, the smallest, to 4/0, the largest. NEC Chapter 9, Table 8, Conductor Properties has information on wire sizes, stranding, and the DC resistance. Stranding. Stranding conductors are made from multiple wires bunched together. Stranded wire is more flexible and easier to work with. According to NEC Chapter 9, Table 8, wire sizes number 18 to number 2 have 7 strands, wire sizes number 1 to number 4 have 19 strands, and wire sizes 250 kc mil to 500 kc mil have 37 strands. A circle and mil is a circle that has a diameter of 1 mil, which is 1/1000th of an inch. It is much easier to express the cross-sectional area of wire in circular mils or thousands of circular mils than in square inches. Conductor ampacities. Conductor's ampacity is affected by conductor material and size, insulation, and installation location. NEC tables 310.16 through 310.21 list the maximum ampacity of conductors for given conditions. It is important to select the right type of insulation to be used. Conductor materials. Copper is the most common conductor material. Material used for wire is determined by conductivity, the ease with which an electric current travels through a conductor. Cost. A lower cost conductor may be a better choice but often depends upon availability. Workability. How easy is it to work with the conductor? Conductor insulation. Early electrical distribution systems used the knob and tube method to install wire. Types of insulation for 600 volt to 1000 volt conductors. NEC Table 310.41 lists the application and construction data for 600 volt insulated conductors. There are many types of 600 volt insulated conductors, each with a different letter designation. Thermoset insulation. There are many types of thermoplastic insulation, including polyvinyl chloride or PVC, polyethylene PE, cross-linked polyethylene XLP, nylon, and Teflon. Thermoset insulations include RHH, RHW, XHH, XHHW, and SIS. They maintain their form when heated. Color coding. Conductor insulation for building wire is letter coded, which indicates the type of insulation for its environmental rating. A color code is also used to help electricians identify wire. There is no standard color code. Protect yourself by testing circuits with a voltmeter. Wire ratings. Wire ratings include the temperature rating. It's based on the allowed ampacity on the ambient temperature plus the heat produced by the conductor. If the ambient temperature is over 86 degrees Fahrenheit or 30 degrees Celsius, the conductor's maximum load current carrying rating must be reduced proportionally. Fixture wiring. Fixture wire is used for interior wiring of fixtures and for wiring fixtures to a power source. The type of fixture wire selected depends on the fixture's operating temperature, so it will have to have the correct insulation. Cable types and applications. Cables are 2 or more insulated wires covered by an outer jacket or sheath and may contain a grounding wire. Cables are classified by the type of covering it has, where it can be used, its exposure to sunlight, and rough use. Non-metallic sheave cable. Non-metallic sheave cable is used for branch circuits and feeders. 2 or more insulated conductors and 1 bare conductor enclosed in a non-metallic sheath. NEC Article 334 specifies the many requirements for type NM and NMC cables. Underground feeder and branch circuit cables. NEC Article 340 specifies where and when to use underground feeder and branch circuits type UF cable. Medium voltage cable. NEC Article 315 covers the use of medium voltage or type MV cable. It is suitable for voltages of 2001 volts to 35,000 volts. It is suitable for wet or dry locations, and it may be directly buried. Metal clad cable. NEC Article 340 covers metal clad cable or type MC cable. Can be used in a wide variety of applications. It may or may not have an outer jacket. There are 3 types of MC cable: smooth metallic sheath, corrugated metallic sheath, interlocking metal tape armor. NEC Article 330.10 specifies the usage of MC cable. High voltage shielded cable. Shielding is added to high voltage cables for protection. It can be cross-linked polyethylene insulation or other insulation, copper shielding tape, conductor of copper or aluminum, semiconductive strand shielding, semiconductive shielding of non-metallic tape wrap, and the outer jacket. Channel wire assemblies. Channel wire assemblies include the cable supports, splicers, circuit taps, fixture hangers, and the fittings. Flat cable assemblies, or type FC, are suitable for branch circuits that supply small appliances or small power loads. Flat conductor cable. NEC Article 324 covers the use of flat conductor cable, or type FCC. Type FCC cable has 3 to 5 flat conductors placed edge to edge and enclosed in an assembly. Type FCC is meant to be run under carpets. Power and control tray cable. NEC Article 336 specifies guidelines for using power and control tray cable, or type TC. It can be used in cable trays and raceways, may be directly buried, and can be used in sunlight. SE and USE cable. NEC Article 338 covers the use of service entrance cable, or type SE, and underground service entrance cable, type USE. It has 2 aluminum conductors, conductor insulation, the bare conductors, a fiberglass tape, and an outer jacket. Instrumentation control wiring. Instrumentation control wiring usually has 2 or more insulated conductor wires protected by an outer jacket. There may also be a shield and a drain wire. NEC Articles 722, 724, and 725 provide information on the application of instrumentation control wiring. Jackets. Shields are used to protect electrical signals in the conductors. They're usually made of aluminum foil bonded to a plastic film. A shield drain wire allows for the connection of all instruments to a common grounding point. PE and PVC jackets are the most common type. And some trade terms to read over and become familiar with for this session. And some review questions for this session. According to NEC Chapter 9, Table 8, number 3 alt AWG wiring has 3 strands, 7 strands, 19 strands, or 37 strands. That would be 19 strands. Using NEC Table 310.16, the ampacity of number 6 AWG type UF copper cable is 40 amps, 55 amps, 60 amps, 65 amps, or 75 amps. That would be B, 55 amps. If a conductor has low resistance, it will conduct poorly. It cannot be used as a service entrance cable. It has high conductivity. It is suitable for use in low temperature application. That would be C, has a high conductivity. Telephone wiring in a plenum space is likely to use Teflon insulation, PVC insulation, PE insulation, or XLP. That would be A, Teflon insulation. Using NEC Table 402.5, the allowable ampacity of number 14 AWG fixture wire is 6 amps, 8 amps, 17 amps, or 23 amps. That would be C, 17 amps. What is the temperature rating of service entrance cable when the cable is not marked? 77 degrees Fahrenheit, 25 degrees Celsius, 104 Fahrenheit, 40 Celsius, 131 Fahrenheit, 55 Celsius, or 167 Fahrenheit and 75 Celsius. That would be D, 165 degrees Fahrenheit, 75 degrees Celsius. Which of the following is the most common type of jacket? PE, rubber, fiberglass, or silicone? I think that would be A, PE. Alright everyone, that was it for that session. The next session will be 2.00, installing conductors and conduit systems, and I'll see you over there.